Hello friends, good day. Welcome to our YouTube channel GKR Soft. In this video, we are going to discuss about client server interface. In our previous video, we discussed about sender receiver interface. I have mentioned all my Autosar videos in the description. You can watch it. What is port interface? As you all knows, to make a communication between two software components, we need a ports. Port can be P port, R port or PR port. And every port will be associated with any one of the interface. Interface can be sender receiver interface, client server interface, mode switch interface or trigger interface. If you will see this picture, here I have configured one P port and this is called as a PP underscore sender data. This is associated with the client server interface. And interface has the details about what kind of data we want to transfer and which operation we want to perform and which data type we are going to select. All this information will be there in the interface. So the interface is one of the important topic. Whenever you are going to work with Autosar, you should have the knowledge about it. Now we can start with what is client server interface. Basically, client server interface works based on the operation communication mechanism. For an example, every client server interface has more than one operation, meaning multiple operations. And client server interface majorly used to make a communication between base software to application. We can take example of DCM. In the DCM side, it's a client, and application side, it's a server. But you can use the client server interface to make a communication between two application software component as well. And every interface can contain multiple operations and each of which can be invoked separately. And single interface can be used to provide multiple operation at once. For an example, here we have a one client server interface. It's called CS interface. This has multiple operations and every operations, each one having input, output or in-out arguments. And in the client server interface, client always initiates a communication, and based on the initiate the communication, based on the request, server will perform and will respond to the request. So this is the way client server interface communication works. Now here, how the multiple clients can communicate to a single server. For an example, here is a single server software component. It's connected with the multiple client software components. But in that case, we have to importantly care about it. This is not possible for a client to invoke multiple server with a single request. So a client call more than one server by making more than one request. So this is the way you can achieve multiple clients and single server. Now, first we have to understand about what is server port, what is client port. Server port means it's a provider port. So this will send the data. That is actually a server. So based on the client request, server will send the data. So based on that, it will dispatch a response to the client request. So this is a one example. This is I have configured as a P port. It has provided com spec and server com spec. Inside the server com spec, we can have an operation. But this is based on your requirement, you can have it. Without provider com spec, you can have a P port name and you can directly mention the client server interface name. The important point what you have to note is server is the provider of operation and client is a user of operation. The same way in the client port side, client port means it's a R port. So it's invoking operation of one compatible server side, meaning client initiates the communication. You can always consider an example of DCM. So DCM is a client, server application software component is a server. So whenever you want to read a data or write a DID or whenever you want to perform any diagnostic related operations, then always client will initiate a communication. So DCM side, the communication will be initiated. So if you will see the example of R port, here RP underscore client, and here also we have used a client server interface. And very important thing is in the interface case, it should be compatible. So whatever the operation used or the data type you selected or whatever the arguments you have selected, everything should be compatible. And the server is the provider of operations and client is a user of operation. This is you have to carefully note it. This is a simple diagram to understand how the client communicate with server. So this is a software component 1. It's a client software component. It has a R port and it has a separate interfaces and it is associated with the runnable entity as well. At the same case in server, we have a P port, runnable entity, and it has same kind of interface. As I mentioned, the interface should be compatible. You can have a separate interfaces, that means unique interfaces for client and server, but it should be compatible. Or you can use a common interface between client and server. But recommendation is always you to use unique interfaces. And in the P port side, it will be associated with the provided com spec. It has an operation and we can mention the queue length. In the required comms R port side, required com spec, and it also has the multiple operations. This is a simple configuration example for how the client server interface will looks like. For an example, see, it's a CS interface. Here is service is false, but this is based on, for an example, is service stack we can discuss in a separate video, but currently you don't need to care about this. But this is only used to decide about whether your software component is the service software component or not. Okay. So here I have selected one operation called client server operation. Here it has many arguments: current data, final data, counter. This is in argument, out argument, and in-out argument. And additionally, you can have a possible error reports as well. So whenever there is some failure, and you can report with the particular error code. So this is also possible in client server interface. But for the client server operation, here we can have a in, out, and in-out. So the important thing in the client server operation is it's not possible to define a default value for arguments. For an example here, I have mentioned direction is input. So here I cannot define a default value. So in runnable entity that invoke a client server operation, a server call point must be defined, because your server call point will decide what kind of communication you are going to choose. That's we can discuss now. Client server, in the client server communication, you can choose the communication way in two ways. One can be synchronous, another one can be asynchronous. Synchronous communication means it's a blocking, and asynchronous communication means it's non-blocking. But in both the cases, client waits response from the server. The important thing in the synchronous communication blocking is your client will wait until get the response from server. You can take an example in a way of when you are reading a data of more than 100 bytes. In the case of DCM, and until get the response from server, the communication path will be blocked. That's what is saying in synchronous communication. But asynchronous communication, we can achieve it in another ways. That's what is called as a non-blocking. But the type of communication like synchronous or asynchronous, that will be purely decided by the client side, and there is no more hold in the server side, completely decided by the client. But it is possible that the same server can be called both synchronously and asynchronously. This is one of the important point, because when you are going to design your Autosar software components or client server communication, this kind of doubts might will come. So it's possible that the same server can be called both synchronously and asynchronously. So this is a general API. For an example, in client server side, you can have a synchronous server call point for making a client side, then RTE API will be generated as RT underscore call. But in asynchronous side, RT underscore call and as well as RT underscore result, both will be generated. We can discuss now in more deeper. In synchronous communication, as I mentioned, client is blocked until the operation result is available. You can take an example of DCM side when you want to read 100 bytes or when you want to write 100 bytes. So until this operation is finished, the client will be, the communication complete will be blocked. Once completely all these things are over, then only the block will get released. Okay. And synchronous side in client server communication cannot be queued, because since it is blocked until get the response, you cannot use the queue mechanism. And server runnable, meaning your function may directly invoked by the client runnable. So the thing is, in the client server interface, it's completely function call. But in sender receiver interface, it's you are sharing a variable. So you can make a RT write API or RT read. Such a kind of API you can make, and you can write one variable of unsigned 8 or unsigned 32. But here, when you want to transfer more bytes of data, you have to go with the function call method. So in the synchronous communication mechanism, RTE will generate an API called RT underscore call. Then here our port name will be mentioned. Then operation name will be mentioned here. So whatever the port name you have selected, that will come after RT underscore call. Then whichever the operation you want to perform, then that will be come here. For an example, you want to read a data, that operation you want to perform. Then RT underscore call, your R port name, then read data. This might be your function call. And you can pass arguments like in, out or out. In means data delivered to server. In-out means data delivered to server and received from server. Out arguments means data received from server. So this is, you can note it clearly. This is a simple configuration to understand about how we can make a client server configuration or client server communication. So if you'll see, this is a server side. We have a port and we have operation invoked event. So this is most of the cases in a way of DCM communication, or when you want to perform diagnostics related, always server side will configure operation invoked event. But everything is purely depend on your requirement and how you really want to design. Okay. But as you all knows that operation invoked event always will be associated with the P port. This is we clearly discussed about in our RTE events video. I have mentioned all RTE events video in the description. You can watch and get more details about how event works and how you can do the event configuration, whether you want to do the event task to mapping is required or not. But in the case of operation invoked event, since it's a direct call in a synchronous communication, you no need to map your operation invoked event with the task. This is a simple interface configuration. Here I have selected as a CS interface, and we have operation called server data. Here only one argument, that's called current data. That's direction is out. That means it's out argument. And another important thing is it's a data type which I have selected this, and you can, for example, state, there is no data like data type like state, right? So here in the down we have to configure state means it's unsigned 8 or you are unsigned 16, something like that. But we will discuss more deeper in our data type video. In Autosar data type video we will discuss more deeper about all implementation application primitive data types. So here you can have a possible error as well, as we discussed. And this is a client side configuration. You will have a R port, and here I want to perform timing event because every 100 milliseconds I want to read a data or I want to initiate a communication. So that's what in that perspective I have designed this configuration. And very important thing here is inside your runnable entity in the server call point, you have to configure a synchronous server call point because you want to make a synchronous communication. So your server call point will be decided. So that means at client side, client will decide which kind of communication you want to perform. So here I have selected as a synchronous communication. So synchronous server call point should be configured. And here we have to mention the R port and what kind of operation you want to perform. As I mentioned, the client server interface should be compatible between server and client. Otherwise, RT will throw the error. And here my runnable entity name is cyclic. So every 100 millisecond, I will make a RT underscore call. Via RT underscore call, I will initiate or I will call the server functions, or I will initiate a communication from the client side until get the response. Client, that means communication path will be blocked. Okay. This is client software component server interface configuration. Like same, here is a client data, current data, but the name should not be same. That is your wish. But here for more understanding, I have selected the same name. But here the direction and everything should be same. And data type also should get matched. And your possible error reference also. So you have to take care everything properly because everything should be compatible. Now, asynchronous communication. Asynchronous communication, client is unblocked. Why client is unblocked and how we can achieve or read the data or we can perform the particular operation, how we can do it in asynchronous, that we will see now. An operation result is accessed when it is available. For an example, server informed to the client. Server will say to the client, hey, my operation is over. You can read your data. My service is finished. Then you can read or you can collect your data. So this is the way asynchronous communication will work. So in that case, two kind of API will be generated. One is RT underscore call. Another one is RT underscore result. As you know, Mike, you guessed it now. RT underscore result will have the result. Okay. For accessing a client server operation, for an example, in the runnable entity that invoke a client server operation asynchronously, two access points must be defined. One is asynchronous server call point. Another one is asynchronous server call result point. These two importantly configured. This should be there. An asynchronous server call returns event must be used to indicate the completion of the client server operation. And asynchronous calls are non-blocking calls, meaning the call immediately returns even if the actual operation has not yet concluded. An asynchronous server call return event must use to indicate the completion or the timeout of a client server operation. And the client is not permitted to invoke the same client server operation on the same port a second time until the previous call has concluded. This is very important point. You have to carefully see it because most of the people gets confused between synchronous and asynchronous. And this is one of the important topic when you are going for an interview. The interviewer might ask the difference and how exactly this works and all. And the result of the server operation must be read by calling the generated RT underscore result API before another call of the same client is allowed. So this is also another important point. Okay, now see here, client side, we will have a RT underscore call, R port, this is we knows, and INOUT means data delivered to server, in means data delivered to server, and we will have the RT underscore result call to get the result of your particular operation. So here you have two arguments. One is INOUT and OUT. INOUT means data received from server. OUT means data received from server. These two API will be used for asynchronous communication. For an example, if you want to understand whether the particular communication is asynchronous or synchronous, you can easily get it by seeing the arguments, or if you have a RTE call and RTE result, then you can easily say that this is asynchronous communication. Now, this is a simple configuration side server. There will be much changes. Here I'm just selected the com spec with queue length of 10 for another understanding, because you should have a multiple example, right? That's what I have created this one. And here client server interface, same kind of operation invoked event, and we have a server runnable entity. If you want to perform something, you can do it. That is the purpose of this runnable entity. And as usual, software common interface configuration, you can have a client server operation. Here calculate is the operation I want to perform, and it has a current data and the direction is in out. Here I have selected application primitive data type. This is a client side, because in the synchronous and asynchronous, mostly you will have a difference in the client side configuration, because client is going to decide whether it's a synchronous or asynchronous, right? So as we discussed, there will be a two access points must be defined. One is asynchronous server call point, another one is asynchronous server call result points. So these two is very important here, and here I have selected the events called asynchronous server call return event. So here asynchronous server call result point should be associated, and very important thing is in the asynchronous side, the server call points, you can have a asynchronous server call point, but very important thing is the asynchronous server call result point should be configured before can be invoked concurrently. Otherwise, RTE will throw the error. This is based on the RTE schema. So here we have inside your runnable entity, you should have asynchronous server call result point and asynchronous server call point. So asynchronous server call point will be with RPort and client server operation. Your asynchronous server call result point will has the asynchronous server call point. That is this one. So you knows now what is the purpose of these two, right? And here I have created the runnable entity, it's client caller, and I have another runnable entity is called RT underscore client result. So this function is called as a client result. So in my asynchronous server call return event, this is mapped with the client result. So whenever the result is available, automatically this will get triggered. This is interface. There will be no much difference between client side and server side. It's normally client server operation, and we have arguments and we have in out. Now we will see how the RTE generator will generate the code in that case. For an example, we have a two runnable entity, right? One is RTE client caller, another one is RTE client result. So in the RTE client caller, we are starting the communication by using the RT underscore call. So this is server like a runnable entity. So if you want to do something, you can do it. Otherwise, you can ignore this right now. So the client caller is one of the runnable entity making RT underscore call. In the client result runnable entity, I'm just reading the result. Based on the status, you can decide whether it's okay, or you want to perform any negative goats. That's also you can do. But here I have just simply have mentioned how the RT underscore call and RT underscore result will get called. So this is the way asynchronous communication will works. Hope you have a clear idea about client server interface and how the synchronous communication works, how the asynchronous communication works. So thanks for watching this video. If you like it, please share it with your friends. If you want to stay with us for more technical content, then please subscribe our channel. Thank you so much. Have a nice day.